Okay, yesterday we started talking about limited network studies. So a limited network is the one which is around a traffic generator. Okay, in the area which is around traffic generator, which is expected to be affected by that facility. It could be an airport, it could be a hospital, a mall, or something like this. Okay, and the problem is the network is very big, so we need to take a sample of the actual values we need. Okay, and that sample can be divided into control counts and coverage counts. Control counts are those which are taken full for the full time duration, and coverage counts are those which are taken for a part of the time period. So control counts, we already have the full count, there is no problem with that. But for the coverage counts, we need to do some conversions, some calculations to find out the full time period count. Okay, so we talked about some guidelines, how many control counts there should be, and coverage counts, and how do we select them, and so on and so forth. Then we looked at one example in which we had 7 locations. One of them, location A, was a control count, the others were coverage counts, and you are required to get the 8 hours data. Okay, so on the control count we had the 8-hour data. For the remaining we only had data for 1 hour from these 8 hours. So we calculated factors which we call as expansion factors. Okay, for each hour we calculated the expansion factor, which was the traffic of that hour divided by the total. Okay, and then we use the expansion factors to convert the hourly volume into the 8-hour count. Now this is another variation of the same study. Okay, so we still have the same network. How many locations we have? 6? 7? 6? Not 7? What does this mean?
6.
Yes, 6 or 7? 6. The power of democracy. Okay? 7. 7. I will do. Okay, 7 locations. One of them control, the other 6 coverage. Okay. Now the purpose is to see the daily variation in the data and try to get a value which covers the daily variation of the data. Okay. In the previous case, we took the counts on all locations on the same day. Okay. 8 hours, 1 day, 1 team at the control, the other team shifting from one coverage to another coverage. But in the end, it was 1 day data. Okay, no other day was observed. Okay, so it could happen on that particular day there was something special, so traffic was not normal. Okay, it was too high or too low. Okay, so what can we do? Instead of relying on 1 day, we can take data on multiple days. Instead of a single day value, we can calculate an average value. Okay, so instead of a single value, we can calculate an average, and that average will be from multiple days. So the variation in the days is already part of the average, right? How do we calculate the average? We add all the values, right? Okay, so an average will cover the variation of the data from one day to the other. Okay, now 6 locations were actually coverage. 6 locations were selected for coverage counts. Okay, so in the previous case, they were spending some hours on, like 1 hour on the coverage location. So they cover all the coverage locations in 6 hours. 6 hours, 6 locations. Now they are saying we will spend 8 hours each day on one coverage location. Okay. Now remember, the data is for 8 hours. Okay. Each day I need data for how many hours? 8 hours. Okay. I'm going to spend each day 8 hours on one coverage location. So I will not shift from one location to the other location on the same day. I'll do one location in 1 day. The next day, for the 8 hours, I will go to the new location. So if I have 6 coverage locations, I'll cover them in how many days? 6 days. Okay, each day I will cover the 8 hours. Okay, since the data is taken on, since the coverage locations need 6 days, so the control will also be same number of days. Okay, it has to be same number of days. This is what I mentioned yesterday as well. Okay, the time period should be overlapping. Okay, you cannot do 10 hours on coverage and 8 hours on control. You cannot do that. You cannot do 6 days here and 3 days here. Yeah, you can do this. 3 days here and 6 days here, you can do that. But you cannot do the other way around. But anyways, the timing has to overlap. The timing has to overlap. The timing has to overlap between the coverage and the control. The timing should be overlapping. So if 6 days are here, then 6 days on the other side as well. Now these 6 days start from Monday, go up to Friday, and then Monday again. So they skipped what? Sunday. And Saturday. They will call as Saturday. Okay. So these 2 days are what? Weekends. Okay. So remember the original requirement was do it for weekdays. Okay. The weekends are skipped. Now I told you what? Which value covers the variation in the data? If you have multiple values. Average. Okay. Can I calculate average for the control count? Can I calculate an average for the control count? Okay. So give me an average for the control count. We have 6 values. You take an average. How much is that? Okay, this is average of 6 days, 8 hour count. Okay, this already covers all the ups and downs. Okay, in the end, the average traffic is around this. Can I do the same for the coverage locations? Yes? Yes? No? Location is different, you cannot do this. Okay, for control, all 6 values are in the same location. Coverage, each value is different, so you cannot do this. Okay, but I still need the average for the coverage counts as well. Okay, so how to do that? For that we will calculate a factor which we call as the adjustment factor. Okay, an adjustment factor. What is an adjustment factor? It is average divided by the daily volume. Okay, average divided by daily volume. Okay, so we know the average for the control count, right? So I'll use the daily volume on the control counts to calculate adjustment factor for each day. For example, Monday 1, the average is 7350. The count for Monday 1 is 7,000. This will be the adjustment factor. How much is it? 1.05. Okay, next one.
0.95.
Next one. Next. Okay.
1.05.
Any problem? Clear? Okay. So now I will use these factors to convert the daily of the coverage into average. Okay. So the adjustment factor equals average upon daily, right? So if you have the factor and the daily, then average equals to what? Factor into daily. Okay. Factors are already here. Daily volumes are taken for the coverage. So this is how we calculate the average for the coverage locations. Okay, so location 1 was Monday 1, this is the count, and for Monday 1 the factor is 1.05. So this value is how much?
686,825.
Okay, next one.
5890.
57.
Hmm?
61. 8190.
62.
64.
Any problem? Okay, daily counts were given. I wanted to convert into average. I calculate the average for the control, the factors, adjustment factors for the control. Then I use daily into the factor to calculate the average. Clear? Okay. Now, in this case, I mentioned yesterday as well, how much time you will spend on the coverage locations is up to you. Okay, but there should be some overlapping between the control and the coverage. If you are satisfying this condition, you can decide how many hours should I spend on the coverage. In this case, in the previous case, we were spending 1 hour on each location. In this case, we are spending how many hours? 8 hours on each location. Okay, and we had the data, or we needed the data for 8 hours. So in one day, I can only do one location. Okay, I can compress this study in less hours. If I decide I will not spend 8 hours on each coverage, for each coverage. Okay, for example, if I decide I will spend only 4 hours on each location. Okay, then how many locations can I do in one day? Total is how many? 2 locations, right? Total data required is 8 hours. I spend 4 hours on each location, 4 on the other. So in one day I will cover 2 locations. And 6 locations will be covered in 3 days. And what did I say? They should be overlapping, right? So if I decide I will spend 3 days on coverage, then for control I will also spend 3 days. Clear? Okay, so this is the next thing which they did. Okay, this table is only for the control count, for location A. Okay, so you can see data is 4 hours, 4 hours. Why 4 hours? Why not 1 hour or 8 hours? Why the data is 4 hours and 4 hours?
To finish it in 3 days.
This is control, right? This is control. This is control count. I am doing it for the full 8 hours, right? But why I am mentioning 4 hours and 4 hours? To overlap. Okay? Clear? Clear? See, when you do this, okay, each time it's not clear, you are losing a grade in the exam. You don't know. Okay, you just wanted to finish. I know, I'm very boring. But it's your grades. Okay, it's not clear, you have to ask. You should ask. Okay, I can see it on your faces. Clear or not? Thank God. Okay. So the timing of the control should be same as the coverage. This is what we mean by overlap. Okay. So if coverage, we are doing 4 hours, 4 hours, it's also 4 hours, 4 hours. To cover coverage location, I need 3 days. You can see 3 days over here. Okay. Now, 4 hours plus 4 hours give me the data for 8 hours. Okay. So I have 3 values for 8 hours for 3 days. Okay. 8 hours on Monday, 8 hours Tuesday, 8 hours Wednesday. Okay. Can I calculate an average for the 3 days? Yes. I can, right? What is the average here? Okay, 6967. Now, which factors were we calculating using the average? We just did in the last exam. Adjustment factor. Okay. So now I will calculate adjustment factor for each day. For each day. Okay. How many days we have? There were 6 days. There are only 3. How much? So it was average upon the traffic of that day. Okay, so average is 6967, average of Monday 7000. How much? 199. Okay, next. One point. Okay, we have the adjustment factors. Now you can see they have calculated the percentage for each 4 hours from the total, right? 42.9%, 57.1%. What are these percentages? We called them yesterday as the expansion factors. These percentages are expansion factors, okay? The hourly upon total. Okay, so 42.9 is 3000 upon 7000, which is my expansion factor. Okay, so the expansion factors are also required, which they have already given us. Okay, clear? No? Expansion factor is, okay, forget about the expansion factor. You understand the percentages, right? It's 4 hour percentage, okay, from the total. So 3000 upon 7000 is 42.9%. So 42.9% is the traffic in the first 4 hours. 57.1% is the percentage in the next 4 hours. Okay, so for each 4 hours, they have given us the percentage of traffic in that hour. Okay. Now, this is the data for the coverage locations now. Okay, data for the coverage location. So you can see each location is on a particular day and how many hours? 4 hours. Okay. Do I know the percentage of traffic in each 4 hour from the control? These values, right? This is the percentage of traffic in each 4 hour, right? Okay, we call them expansion factors. These factors are called as expansion factors. They can be for 4 hours. Yesterday we calculated them for 1 hour. Okay, but it is basically the hourly upon total. Okay, in this case my hourly is 4 hourly and the total is total. Clear? Okay, so first thing I need to do is convert this, convert the 4 hour volume I have to 8 hours. Okay, I'll convert the 4 hour volumes to 8 hours. Okay, these are the values. Let me put it on the other side so we can see everything. Okay, the values which are taken in 4 hours, for each 4 hour you have the percentage which is supposed to be there. Okay, so to convert it to 8 hours, I will do the average directly. Okay, average 8 hours. So I will take the 4 hour count. For example, it is 2213. This count is for 4 hours. Which 4 hours? 12 to 4, right? 12 to 4 and on Monday. 12 to 4 on Monday. Okay. So what is the percentage for 12 to 4 on Monday? 42.9. Okay. So this is the expansion factor. I will divide by this factor. Okay. So this will become 8 hours. So from 4 hours it will become 8 hours. Okay. The next thing, but this is 8 hours of Monday. This is not an average. Okay. This is 8 hours of Monday. This is not an average. So to convert it to average, like we did in the previous example, I multiply with the adjustment factor of Monday, which you already calculated. Okay. How much is that? Yes, how much is it? Anybody else? 2213 divided by 0.429 multiplied by 0.99. How much? Say again. 5201. Okay, 5201.
What's second one?
Come on. Okay, 5201. Okay, this is 3000. It is Monday 4 to 8, right? So you will pick the factor of Monday 4 to 8, 57.1, 0.571. So divide by that factor, and it is still Monday, so multiply by the adjustment factor of Monday. Okay, this is how we got 5201. Next one.
5820. 5820.
Next.
405.
405.
8.
Next.
863. 6673.
Any problem? Okay. Because the counts were shorter than the total, we had to use the expansion factor, the percentages. And the counts were for 1 day, and I wanted an average, so I used the adjustment factor. Clear? Okay. So we have covered now all types of cases. Only adjustment factor, only expansion factor, and both of them. Okay. Okay. Any problem? Any question? No? The next one is more difficult than this, and I will not solve it in the class. Any questions? Okay.
Can you just go back? I will take a picture.
Okay. So we have a new network now. We have 10 segments. Location A, control count. Other 9 locations, coverage counts. Okay. So on location A, they will do the full count. On other locations, they will do part of the count. Okay. Now let us see what, and they are doing it using pneumatic road tubes. Again, they have only 2 sets of tubes. Okay. So at a time, they can only do it at 2 locations. Clear? Okay. The first table is the count taken on the control location, on location A. The first one is the control count. The first table represents the control count, which is taken on location A. And the second table represents the count which is taken on location, other locations, other coverage locations. Now you see, look at the time, there's a gap in the timings, right? There's a gap in the timings, right? How much is the gap? 15 minutes, okay? We need the gap in manual studies. We need the break. There's a break, right? We need the breaks in manual studies. People need the break. Okay? Road tubes don't need the break. So why do we have the gap? Moving. Okay? This is the gap which we have to put for movement of the road tubes. Okay? So road tube is here, then you have to shift it to another location. So you need the gap here. Okay? And then, as I mentioned earlier, they should be overlapping in the timing. So you need the gap here, you have to put the gap there as well. Okay? Now, if you look at the values, if you fill the gap, how many total hours you have? Like if you add the 15 minutes, 12 hours, right? 12 hours. Okay, 12 hours. From 8, and if you fill the last 15 minutes, it will be 8, right? So 8 to 8, 12 hours. Okay, so I need the 12-hour count average. I need the 12-hour count average, and this has been taken on 3 days. Okay, so this is similar to what we have done earlier. Okay, what is the first step? The first step is to fill the gap because of this break. So what should I do? This is taken for 3 hours 45 minutes. I want it for 4 hours. So what do? adjustment factor? Adjustment factor was for this break. Yes.
Use equation.
Tell me.
From chapter 2, I think.
From chapter 2, yes. You need the equation. The count is taken for 3 hours 45 minutes. I have to convert it for 4 hours. What should I do? I need an equation with log and e to the power, right? Sine square upon tan square. Yes, yes. See? Genius. Compared to you guys, he's a genius, right? Huh? Right or wrong? Why are you laughing? You should be crying. He's the one who should be laughing. Okay. So, each value, you pick the first value, for example, it is 3000. So, 3000 divided by okay, 3000 or whatever the value is divided by 3 hours 45 minutes into 4. Okay, and those who are thinking why 3 hours 45 minutes is 3.75, refer to the genius. Okay, I cannot tell you, like I cannot explain to you. It's magic. Okay, clear? Okay, should I do it with this value or with all the values? Should I do this step for all the values or only value from the first table or the second table or a particular value? All values, right? All values are taken for 3 hours 45 minutes and need to convert all of them to 4 hours, right? Clear? So this step will be done with all the values. Okay, you pick all the values from table 1 and table 2 and you do this. Okay, so all values will be converted to 4 hours. Okay, clear? Then for each 4 hour you calculate the percentage from the total. We are calling it the expansion factor. Okay, so you will have the total of each day, total of Monday, total of Tuesday, total of Wednesday. Okay, from which table? The first one or the second one?
Yes.
The first one. Because in the first one all values are for the same location. Okay, so you will do the total for each day and you will calculate the percentage or the proportion for each 4 hour period. Okay, and we call it what? The expansion factor. Okay, next thing, you have the 3 days of data for the control, right? Okay, I can calculate an average for the control. Okay, and from average we calculate which factor? Adjustment factor. So you will calculate the adjustment factor for these 3 days. Okay, so now you have the expansion factor for each 4 hour period and you have the adjustment factor for each day. Okay, so now what do we do? For example, now you pick the value from here, 1900. Okay, so you pick this value and what do we do with it? Okay, first thing you have to do is the same which we did with the earlier one. Okay, you have to do this. Okay, now it's converted to 4 hours. Then you will divide the answer with the expansion factor of these 4 hours. Okay, the proportion which you will calculate from the first table, the expansion factor. Okay, then this whole thing, so this will become 12 hours of Monday because the count 1900 is taken on Monday. So this will become 12 hours count of Monday. To convert it to average, then I will multiply with the adjustment factor of Monday. Okay, so this has to be done for all these 9 values. Okay, this one will remain the same. Expansion factor will change for each 4 hour period. and adjustment factor will change for each day. Okay. Any questions? Okay. Now I told you that we are using pneumatic road tubes here for counting the data. So pneumatic road tubes gives you what? Number of axes. Okay. So I don't want number of axes, I want number of vehicles. Okay. So for that we have to do a manual study. So on that location, one of those locations, they did the manual study and these are the values. So you can see the axles here and you can see the number of vehicles here. Okay. So I want to calculate axes per vehicle. So what do I do? I want to calculate axes per vehicle. I want number of vehicles. How many vehicles you see here? 7, 6. How? 7, 6. Okay. Now I want number of axes. 2780. Why? 2 plus 3 plus 4 plus 5. No? 2780. What did we do? Yes? Multiply. Okay, you have to multiply. Okay. 2780. Okay. So axes per vehicle is how much? 2.18. Okay. So once you get this value, this one, this will be number of axes. You have to divide by 2.18 to convert to number of vehicles. Okay. And again, this will be done for all values. All values. Even for the control, because even the control is number of axes. Okay, so even the control has to be converted to number of vehicles. Clear? This procedure is written here, and you can see we are covering the concepts from chapter 2 as well as this one. Okay, the concept, the first step and the last step was done in chapter 2 as well. Okay, and the remaining steps are from just the same example which we covered last time. Okay, clear? So you do it. You should do it. Okay. And these are the values you can check, the axle count as well as the vehicle counts. Okay, in limited network study, another thing which we are interested in is vehicle miles traveled, VMT. Okay, VMT stands for vehicle miles traveled. Another name for it is VKT. So VMT is vehicle miles traveled, and VKT is what? Vehicle kilometers traveled. Okay, and how do we calculate it? We take the volume multiply by the length. Volume multiply by length. Okay?
Which length?
Length of the segment. Okay? So for example, these are the volumes from the previous example, and we know that they were taken for 8 hours, right? The first example. And each segment, assuming that all the segments have a length of 0.25 miles. Okay? So if you want VMT, then it will be this number multiplied by this one. Okay? 6967 multiplied by 0.25. This will give you VMT of segment A. Okay? And so on and so forth. Clear? Okay? And if you want the total VMT, we can add them together, no problem. If they are in the same segment, we can add them. Okay? Now volume is for how many hours? The volume is for how many hours? 8 hours. And what about the last example? 12 hours, right? 12 hours. So that means if I am multiplying volume for VMT, then VMT also has, or it can also have different number of hours, right? So if I take it here, then I took the volume for 8 hours. So this is VMT for 8 hours. If I do it for the last example, the 12-hour example, then the VMT will be for 12 hours. You can have VMT for peak hour, for the whole year, depending upon the volumes. Depending upon the volumes. Okay. What is the purpose of VMT? The VMT tells you about the importance of a segment. Okay, how important a segment is. Okay, So VMT is the combination of two things, right? Volume, length. If volume is higher, that means more users, right? More demand. Segment is important. If length is higher, that means it is serving more area, it's covering more area. So it becomes more important. Okay? So in any case, it becomes important. Once you have done a network study, you can represent it as a network flow map. Okay, so this is a network flow map. It looks like a map of an area showing all the streets, but the width of the streets are scaled according to the flow. Okay, so this segment has more flow, so you see more width. This segment has less flow, so less width. Okay, so the point is, when you look at the map, by just looking at the map, you have an idea which streets are more important, having more demand and so on. Okay, so these are smaller, less demand. They are bigger, more demand. Okay, clear? Yeah. A bigger version, a larger version of limited network study is a statewide counting program. Okay, so a statewide counting program is a study done for a bigger network. Okay, what is the size of this network? The state. Okay, so we have three states, right? Liquid, solid, gas, right? Huh? State means what? Yeah, the whole area, okay, the whole country. If it's a small country, okay, then the whole country. If it's a big country, then state can be one part of the country. Okay, so Saudis have provinces, US has states, Bahrain has Bahrain. Okay, so okay, there are other small countries as well. Singapore is maybe even smaller than Bahrain. So you will not put different parts for such a small networks. Okay. What? Yeah, you should be proud of it. Okay. So like I said, the entire political boundary becomes a network. Okay. Why do we do statewide counting programs? We want to know AADT. What is AADT? Okay, so we want to know for each segment, if possible, for each segment, we want to know the total, the average traffic for the entire area. Okay. We also want to know ADT. What is ADT? Average daily traffic. So this is for less than 1 year. It could be for each month or each season or week. So this will tell you the variation in traffic in the year. Okay, how traffic goes up and down in different months or different seasons. Okay, so we want to know that, and we also want to know VMT. So with that we know which roads or segments are more important than the others. Okay, clear? Okay. For doing the statewide counting program, the first step is classification of the highways. Okay, you pick the map of your area and you classify the highways. Okay, what is the classification of the highway? Okay, so arterial, local, and they can be major arterial, minor arterial, urban arterial, rural arterial. So whatever classification you are following, mark them on your map. Okay, classify that this highway belongs to this type, this highway belongs to this type. In the end, you should have this. Then, now we are talking about the entire state, right? So it's a big network. Okay, so for every type of highway, and yes, yeah, for every type of highway, you should select some control count locations and some coverage count locations. And obviously, it will not be one. Like in the previous example, it was one, right? One control count. Here it will be more. Okay, but for every type of highway, you should select some for control count, some for coverage. Okay. Then what is the difference between the statewide program and the limited network study? The difference is in the time. Okay. The previous example, the whole study was done in how many days? 3 days, right? 3 days. The one before with this, the adjustment factor was done in 6 days. After 6 days, the project is finished. The project is finished. Okay. Statewide program is done by the governments. Okay. So they update their data on regular basis. So there is no specific timeline for this. Okay. For limited network study, the client says, okay, I want to know what is the effect of my facility on traffic right now, and that's it. You do it one time and it's done. Okay. But the government, like, they collect the data for the population, right? They don't collect data for 1 year. The population in this year was this much. After that, we don't know. They do it after 10 years. No. They do it every year. They update the data. So statewide programs are governmental programs in which data is collected and updated every year. Okay. Clear? Okay. Any questions?